One of the most common troubleshooting scenarios is trying to understand why your system may be slow or unresponsive. Something's running, you don't know why. We're going to discuss how to take a deep look inside Windows to accurately account for all of the CPU time spent by the threads inside the processes running on your system. Now, when your system is feeling sluggish, whether it be a server or workstation, most of us reach for Task Manager as a way to take a look at what's running. But as we're going to see, it may not accurately answer the question of what's running, why your system is slow.
So I'm going to pull up Task Manager, and its default configuration, it displays a tab called the Applications tab, which isn't terribly helpful for tracking down process resource usage. So typically, you'll go to the Processes tab and look at the processes running on your system, sort by the CPU column, and try to identify the ones consuming the most CPU. The problem with this display, though, is that Task Manager doesn't show you inside of processes that have multiple components. And we're going to see some multiple component processes later as we go along here, where it's difficult to figure out exactly which component's the one in that process that's accounting for the CPU. Further, Task Manager accounts for interrupt and DPC time, something we'll learn about a little bit later, in the system process or the idle process, and it's difficult then to break that out and understand what's going on with your system if you see CPU usage in those processes.
Also, remember, Mark, when we were investigating this, we found that a lot of these processes that have supposed zero CPU time, in fact, there is activity by pieces of those processes that are not showing up in the system's time accounting mechanism. So we're not really seeing any close representation as to what's actually running on your box right now.
Right.
So before we take a closer look at the Process tab and how to look at process activity, let's define the terms. What is a process and what is a thread? A process is an instance of an executable. For example, when you start Microsoft Word, you've created a process running an instance of winword.exe. Process defines a private address space. The Windows kernel provides separate protected address spaces for processes so that a bug in one process can't affect the memory contents of another process. The address space is shared among the threads running in that process, as well are the open handles. So when files or other resources like registry keys are opened, those are resources accessible to the process in total. And the final main component of a process is the security token, or the credentials. That would be the username, the groups that that user is a member of, and the privilege list.
So what is a thread? As Dave mentioned, processes can have one or more threads. A thread is an execution context. It's what actually Windows schedules to go and execute code. So it's really inaccurate to say a process is running. What you're really saying is a thread within a process is running. And as Dave mentioned, a thread shares everything about the process. It shares the address space, it shares the handle table. So any thread in the process can execute any of the code, access any of the data in the process, or access any of the open resources that the process has open. Every process starts with one thread to execute the main part of the program that the process is hosting. But processes can create other threads as well.
Now, what's the point of having multiple threads in a process? Because it actually adds to the complexity of the programmer's job, because now the programmer has to synchronize access to the shared resources within the process among those threads. Well, one is it gives the illusion that the application is more responsive. For example, in Microsoft Word, when you go to print a long document, while the print spooling is occurring, you're allowed to continue to edit the document. How's that happening? It's because Word creates a second thread that is then sending the data to the print server, and that thread is separate from the thread that owns the user interface. So both threads are allowed to execute some work, wait, and then while one is waiting, the other can pick up and execute. So basically that means overlapping I/O activity with compute activity. The other important benefit of dividing an application into multiple threads is the ability to scale across multiple processors. So if a process only has one thread, adding additional processors is not going to allow that application to take advantage of the additional processors. This is becoming more and more important as default configurations, such as the new dual-core chips from Intel and AMD, are becoming prevalent not only in desktops and servers, but now also in laptops or mobile devices. So how well an application divides itself into multiple threads and then takes advantage of the multiple processors is going to become a more and more important attribute of applications on Windows.
So if we know that threads are actually what runs on Windows, let's go back to Task Manager and talk about what it's showing us in this Applications tab. The Applications tab is actually mislabeled because Windows has no inherent concept of an application. Further, if you look at the column header here, it's labeled task, and Windows has no inherent concept of a task either. Well, other than tasks that you would schedule as part of the task scheduler to run periodic programs. But, so what are we looking at here? We're not looking at applications, we're not looking at tasks, we're not looking at processes, which you see on the Processes tab. What we're actually seeing here is a list of some of the top-level visible windows on the current desktop. And the reason that I say some is that there's a couple of windows that are actually not displayed here. One of them is Task Manager itself, which I think is a little embarrassed to show itself in this list. Another one is the Explorer desktop window, which is also visible as part of the taskbar there at the bottom, but not in this list. So if these are windows and not processes or threads, what does the status mean? The status actually reflects the state of the thread that owns that window, because each window has a concept of an owner thread. And a thread that is in the running status here is one that is waiting for Windows input.
So let me just see if I got that right. Running means waiting.
Mm-hmm.
And then what does not responding mean?
Well, not responding, which is the other status you might see in there, means that the thread is not waiting for a Windows message. It's off maybe doing something else.
I think I get the picture. So running is waiting and not responding is maybe running.
Exactly. It's a little bit contra-intuitive, but
I guess from the dumb user's point of view, the application, which is really a window running, means it's available for user input.
Right.
Because
so if
it's
not
running.
If you start typing or using the mouse on it, it's going to respond to you.
So maybe running should be might respond, and not responding is actually
That'd probably
clear.
be a little more accurate.
Okay.
Yeah.
The other thing, Mark, is in a terminal server environment, if you bring up Task Manager in a session and I bring up Task Manager in a session, we don't see each other's windows. So I like to kind of call this tab some of the windows in my session, because it is a session private list of windows.
And that'd be a more accurate description. Better certainly than applications or tasks.
Now that we understand the Applications tab, let's go back to Task Manager and return to the Process tab. This is a list of objects that we've described. A process is a container that has one or more threads, a private address space. We discussed that processes don't run, threads run. But there is some information that would, if present, be helpful to identify these processes. For example, the full path of the image name is not shown. Other descriptive information that might be available could help. So the name of the exe sometimes is obvious. For example, there's Process Explorer. Sometimes is not so obvious, like this first one on the list, mscorsvw.exe. Well, what is that, and where is it coming from, and who created it? So those are some of the pieces of information that Task Manager doesn't currently show.
Another problem with Task Manager, let me pull it up again here, with the Process tab, is that there are a number of processes that actually host one or more components within them. And so the name of the process, if it's consuming CPU, really doesn't tell you what within that process is responsible for the CPU usage. There's a few examples that right here on the image list, if we scroll down, the system process, which hosts multiple system threads. If that's consuming a lot of CPU, the question is which system thread is consuming the CPU. These service host processes we're going to see host Windows services, one or more. And if one of these is high CPU usage, which of those services are responsible? DLL host is another example. iNetInfo, which hosts multiple ISAPI DLLs, is another example. And Run DLL, which we also see here, which hosts control panel applets. If one of those is running, which control panel applet is it hosting?
So really we need more information, and that's our lead into Process Explorer, which I like to affectionately refer to as soup for Task Manager. And I can say that because Process Explorer really illuminates a tremendous amount of detail about process state, thread state that we're going to be looking at closely that make it much more easy to get back to the answer to the question, what's running on my system, and why is my system slow, and where did these processes come from?
Let's talk for a minute about how Process Explorer works before we actually show you it in action. It uses a number of undocumented functions. Unfortunately, Microsoft hasn't exposed all the detailed information Process Explorer likes to obtain through documented Windows APIs, and so I was unfortunately forced to use undocumented functions to get that information.
Do you feel bad about that, Bill?
I don't really feel that badly
because it is against the software license.
To use undocumented functions?
Well, the way you got that information.
Maybe, but I don't feel bad about it.
Okay.
You got to do what you got to do. It also, when you launch it the first time and you're running in an administrative account where you can do this, it loads a device driver to help it obtain some information and help obtain it in a reliable way. That device driver, for example, is used to help it get the stacks of kernel mode threads, which can be useful for identifying what a thread is doing. It also helps it get the names of corresponding to open handles for handles that aren't in your current session, for example. The same version of Process Explorer runs on all versions of Windows, from Windows 95 all the way up to Vista. It even runs on 64-bit versions of Windows XP and 64-bit versions of Vista, though the same image runs on all these platforms. It contains within it versions of the driver and versions of the executable appropriate to whatever platform you're running on. So even if you're running on 64-bit Windows XP, you download the executable, which has to be a 32-bit executable to work on the other 32-bit platforms, and it extracts from itself a 64-bit version that it then launches. And we're going to see that graphically a little bit later using Process Explorer itself.
But Mark, I know when I go to Sysinternals that there's a download link on the bottom separate for Windows 95 for 32-bit Windows and 64-bit Windows. If it's the same file I'm downloading, why have the separate links?
That's basically just to track what kind of OS people are using. And what we've seen over time is less and less people using Windows 95 or downloading through that link.
Just curious, what is the download rate for Process Explorer, roughly?
250,000 a month, roughly.
Wow, popular piece of freeware. Now, there are some related tools to Process Explorer that we'll take a look at later that provide command line access to some of the information and details that Process Explorer provides. For example, handle.exe provides a command line interface to look at open handles in a process and even close them. List DLLs shows the loaded DLLs in a process. And there's another group of command line process tools we'll look at later called the PS Tools Suite, like PS List, which provides a basic process list similar to Process Explorer's output.
So let's open up Process Explorer at this point and immediately see a number of differences from what we saw when we looked at Task Manager's process list. For example, you see the processes are organized in a tree-like data structure, or tree-like structure. And what this tree-like structure represents is the parent-child relationship between processes. You might not have realized that there is a parent-child relationship because Task Manager simply shows you the flat list organized by process name. But the process tree can help you identify the purpose of a process just by the fact that one process is the parent of another. For example, services.exe, you'll see, is the Service Control Manager application. This is what's responsible for launching Windows services. So that immediately tells you that any child of it, which is shown here directly beneath it and indented one level, is going to be hosting a Windows service. And it's no coincidence that there's a pink color highlighting on processes in that part of the tree because Windows services are highlighted in this pink color. You'll also see as you scroll down a number of other highlighting colors, for example, this blue color and this purple color. We'll talk about those as we go on a little bit later. But one of the colors that Process Explorer uses to help you identify changes in processes that are coming and going, which are very hard to identify in Task Manager's process list. You've got to really watch carefully to see things coming and going in that list, is something I called difference highlighting. Difference highlighting will highlight a process that's born, in other words, not in the previous display, but in this one, in a green color, and highlights ones that have exited in a red color. So immediately you can see if processes are being born or dying by looking for those particular colors. I'm going to change here in the options menu, the difference highlight duration, which is by default 1 second, to 5 seconds so that we can easily see the processes that I'm about to create and exit. And I'm going to launch Notepad to demonstrate this. And down there at the bottom, you can see the new Notepad show up in green, and that highlight color will disappear after 5 seconds. Now I'm going to exit that Notepad, and it shows up in red, indicating that it's gone.
That one feature alone, Mark, helped me diagnose a slow server that was running very slowly. The administrator brought up Task Manager, sorted by the CPU percentage, and there was no process in the list that was accounting for the slowness of the server. So I ran Process Explorer, and before I even started looking at the details, I saw waves of red, waves of green, waves of red, waves of green, and it turns out there was a Windows service process that was creating a child process that ran for a very short period and exited, recreating that same process, recreating the same process. And that kind of fast process birth and death is something you simply wouldn't see in Task Manager. And it was a bug in a script that was repeatedly launching this process.
So the default refresh, the interval for Process Explorer, just like Task Manager, is 1 second. But that might be too slow or too fast for what you're trying to watch. So if you go to the View menu, you can change the update speed here to anywhere between 0.5 seconds and 10 seconds. You can also see that you can pause the display, and you can do that to get a snapshot view of what's going on if there's lots of activity. And you can see that there's an accelerator for that, the space bar. So I'll pause it. You see the paused indicator there in the status bar, and when you're done examining what you need to examine, you press space bar to release it and go back to the normal refresh rate. The next thing we'll talk about is the way in Process Explorer that you can choose different columns, just like you can in Task Manager. The default column view that we've got here will have the process ID, the CPU usage, the description of the process, and the company name. Process Explorer is actually getting the description and company name directly from the executable file itself. Developers can choose to add version information to their image, which is helpful for identifying the purpose of the image. Process Explorer displays that for you in these columns.
How trustworthy is that information? I mean, can anybody put Microsoft Corporation for a process?
Yes, anybody can do that, and malware is wanting to look more and more like it's a legitimate part of your OS so that it looks innocuous. And we're going to see how Process Explorer helps you identify malware that's pretending to be from Microsoft in a little bit later. If you want to change the columns or pick different ones, there's a few ways you can get to the column selector. One of the easiest ways is just to right-click on the column header and choose Select Columns. And you can see that there are 3 tabs here related to choosing columns for the process view, which is what we're looking at. The process image columns, process performance-related columns, and process memory-related columns. These other tabs are for choosing columns for other views, including the status bar. You can pick what the information you want displayed in the status bar itself.
Now, because there are so many column options, Mark recently added the ability to save column settings in what are called column sets. So on the View menu, I'm going to save the current column definitions as a column set, and I'm going to call it the default column set because that's what we're looking at. Now perhaps I'm interested in adding some columns related to a memory troubleshooting exercise. So I might go to the process performance, process memory tab and add page faults, private bytes history, and how about the working set size.
Sounds good.
I'll click OK, and because those columns are something I want to see more clearly, I'm going to get rid of the description and company name columns. So let's get rid of description and company name. And this looks like a good setup for troubleshooting memory-related issues with processes. So I'd like to save that, so I'm going to go back to the View menu, choose Save Column Set, and now I'm going to name this Memory Troubleshooting. And I can use that column set, but when I'm done, because I really like the default view that Mark has, I'm going to go back to the View menu, and I can load the previous column set, which I called default, and that notice also has a keyboard accelerator Control 1. So now I've got Control 1 and Control 2. Control 2 goes back to the memory troubleshooting columns, Control 1 back to the default columns. Very nice feature.
Mm-hmm. And if you need to at any point change the names of those column sets, or you want to change their bindings to a different control accelerator, you can come to this menu, change the names, move them up or down. But I like the way you configured it, so let's leave it that way.
Okay. Let's take a closer look at the meaning of the different colors that are used to identify the different types or classes of processes in Process Explorer. So to do that, I'm going to go back to Process Explorer and bring up the Configure Highlighting dialog. And as we look at the different colors, and notice the first 2 are the ones that we saw earlier in the refresh highlighting example. Green represents new objects added to the list. Red represents an object that's been removed from the list. So that would, for example, apply to processes. Also other objects we're going to see in other Process Explorer displays. The next 2 colors, own processes and service processes, are probably the most common ones you're going to see in your display. An own process is a process that is your own. It is running under the same security credentials that Process Explorer is running under. So for example, if I scroll down in the display, I see Explorer.exe highlighted in that default blue color and its descendants, because by default a process inherits the security credentials of its parent. Were I, for example, though, to create a process with a run as command to run under some other account, that process would not be considered my own and would not have that blue highlight color. The pink color that we saw earlier in the top of the list represents a service hosting process. That would be a process hosting one or more Windows services. And we'll take a closer look at that later in our discussion. Next on the list are processes that are running an instance of what's called a packed image. A packed image means an executable whose on-disk version differs from what's in memory. For example, this process here, which you'll notice if I hold the mouse over the tooltip shows, is Avant Browser. is a browser front end that Mark and I use for giving tab browsing and other useful internet browsing features. Now that packed image is highlighted because there is some data encoded in the exe that is unpacked and differs from what's loaded in memory. This is not a malicious process, but packed images is one way that malicious software may try to hide descriptive text or signatures that would alert some kind of virus scanner or anti-spyware program. So be alert to a packed image and make sure you recognize and identify it. If we look further in the highlight colors, jobs. Processes that are a member of a job are highlighted in a brown color. We'll talk about jobs in more detail shortly. And then finally, .NET processes. A .NET process is a process that's running managed code. It's highlighted in a bright yellow so that we're alerted to the fact that we have managed code on the system. But let's go take a look, Mark. Are you running any .NET applications?
No, I try to not to, Dave.
Okay, so
we're not
you're
running any.
kind of the old school C assembly language programmer. All right, so if you're a .NET programmer or you're working with .NET programmers, there's some details that Process Explorer illuminates about a .NET process, such as the app domains inside the process and also access to .NET performance counters that could be useful for somebody that's debugging or supporting a .NET application.
So Task Manager has a number of window manipulation commands that you can get to through the Applications tab. And Windows themselves have a menu, a system menu, where you can pull it down and do things like minimize, maximize, and so on. Process Explorer gives you access to those same menu-related commands on the right on the context menu here. If the application does have a window, so some processes don't have windows, like for instance this one doesn't, so the menu entry would be grayed. But let's go back to, for instance, Task Manager, which does have a window. And if you go to the window menu, you can see bring to front, restore it if it's in a minimized state, which it is right now, minimize it or maximize it, or close. Since we're done with Task Manager for this presentation, I think we can close it. What do you think, Dave?
Get rid of it.
And close does the same thing that Task Manager's end task does, which is sends a close message to the thread owning that window. And if the thread doesn't respond to the close message, the window doesn't disappear. After a few seconds, the Windows will bring up an end task dialog, which lets you either cancel the close operation or terminate the process using the standard terminate process API, rather than just waiting for the window to disappear.
Now, Process Explorer has one other very useful window-related control operation, and that's the window finder tool. And so I know I've had occasions where a window pops up and it's not clear what process is associated with that window. So what Process Explorer provides is on the toolbar. If we go back to look at the toolbar, there's a little crosshair. I'm hovering my mouse over it right now. It says find the Windows process, drag over the window. So let's first make two different windows that would appear in the process list with the same name. I'm going to run the command prompt, and then I'm going to run the command prompt again a second time. I'm now going to click on the Process Explorer Find Window toolbar icon, and notice Process Explorer is minimized, and as I move the mouse around, it highlights the window that I'm hovered over with a black border. I'm going to unclick the mouse, and you'll notice that Process Explorer highlights on the bottom of the screen the process that owns the window that I dragged the Window Finder tool over.
Now, if you really like Task Manager's Applications tab with its concept of statuses, running and not running, and even the list of windows, Process Explorer gives you the ability to basically recreate the Applications tab through choosing a few columns here. I'm going to go to the Select Column dialog and add the window title and window status columns. Now, if we scroll over, we can see for processes that have windows, that have titles, we see the title name here in the column, and we see the corresponding Task Manager related status. If we sort, for example, by window title, we've just basically recreated up here in the top, in these column at the top of the display, the Applications tab from Task Manager. So no reason to ever use Task Manager anymore, Dave.
Okay. I promise not to open it again. Now, Process Explorer provides a number of control capabilities for operating on processes. Let's take a look at those, starting with, if we return to Process Explorer, the ability to change the priority of a process. So if I do a right-click on the process, like in Task Manager, there's an option to set priorities. Now, what's displayed here in addition to what Task Manager shows is what the actual priority value is for the threads in that process. The number shown is the base priority for the threads. The programmer is allowed to adjust the thread priorities relative to that base. And one interesting point about the relative thread priorities that the programmer has access to is there's a couple of settings that are fixed relative to the process priority class. So for example, if a malicious process set one of its priorities of its threads to one of these fixed high levels, changing the process priority in fact won't affect the thread priority at all. Later we'll see how to look inside a process, and then we can see individual thread priorities. Process Explorer also has, like Task Manager, the ability to kill a process, and that's right-click kill or just the delete key. One of the things I like is the ability on the options menu to get rid of the confirm kill. So if you'd like to quickly kill a process without having the message box up, you can deselect that and then just press the delete key and the process will disappear. The process tree, if it's still connected to its children, can be eliminated with a single click, right-click, kill process tree. That's also something you can find in Task Manager. But be aware that the way that Windows creates and maintains the process tree is such that if a process's parent exits, then there is no connection between the child and what was the parent. So for example, if process A creates process B, which creates process C, B exits in the middle, doing a right-click kill process tree on the first process, process A will not kill process C. Restart and suspend. Restart is handy for processes that have been launched by a shortcut with a number of switches. So for example, if I do a right-click restart on this piece of ActiveSync, it's going to use the same exact command line switches that were passed to start that process in the first place. It'll kill it and then recreate it with the same startup switches. Suspend is an option we're going to look at more closely in a moment. Allows you to suspend the threads in a process. It doesn't kill the process, it puts it on ice while you go do something else, and then you can resume the activity. And then finally, web search. If you see a process in the list, you're not sure what it is, you can do a right click and choose, of course, by default, Google. But because we want to be Microsoft friendly, Mark added in the options list the ability to configure the search engine to be what we really should be using, Mark, right. MSN Search.
And which is what we configure it for when we go to Microsoft.
So let's change it to MSN Search, and then when we do a right click, it now says MSN Search. And that just is going to send that exe name to the search engine and hopefully bring up some useful articles explaining what that process is.
So we've been doing a lot of talking about killing processes, Dave. Yeah. Let's talk about recreating processes or starting new processes. And you can do that the same way you can in Task Manager with the File menu. There's a few different options, though, that you get here that you don't get in Task Manager. Besides the basic run, which launches the standard Windows Run dialog, you get Run As. So this is the same thing as what you'd get if you right-clicked in Explorer on a shortcut and selected Run As a different user from the menu. When you launch a process in this way, you get asked for alternate credentials. So potentially you can enter a different username and password and launch it under a different account that might be required to get the functionality out of that process. Another option here is the Run as Limited User, which gives you the ability, if you're running in an administrative account, to lower the rights of a particular application. This is basically bringing you low rights IE, which Microsoft includes in Windows Vista, to Windows XP and previous versions of Windows. So if you choose Run as Limited User, this version of Command Prompt is actually running as a limited user. We're running the rest of the desktop in an administrative account, and we'll actually use Process Explorer itself a little bit later to show you exactly what the difference between the security context of this process and the other ones like Process Explorer are in terms of the Windows security model.
So are you telling me, Mark, that you actually run as a local administrator? Isn't that a bad practice?
Yeah, I do, Dave. Thanks for pointing that out.
Well,
what do you run as?
Well, I tried running as a normal user, but I gave up. Too many apps didn't work. So I'm waiting for Windows Vista. That'll solve all my problems. Now, let's go back to the suspend feature in Process Explorer. Suspend allows you to take the threads in a process and literally put them on ice. They will not be executing until you resume them. And this could be useful if you have a CPU-intensive process, but you temporarily need to have access to the CPU to go do some other operation. For example, check your mail, check something on the web. The other thing the suspend can be useful for is to temporarily gain access to network or disk bandwidth. For example, if you're doing a large download or a file copy from a file server, you now need to do something else on the network. Go suspend the process doing the file transfer. For example, that might be iExplorer.exe, could be Explorer.exe itself. the threads are suspended, no network I/O is being done, go do something else, start another copy of Internet Explorer, and now you've got 100% access to the network bandwidth. Likewise, it's a easy way to pause disk I/O. If you've got some disk-intensive application that's thrashing the disk, suspend the process temporarily, go do what you need to do that accesses the disk, and then go resume it. Now, just a warning about suspending processes. It is possible, and it's happened to me, that I've suspended a process and that caused the threads in that process that were holding some resource to not be able to give up that resource, which caused other things to start to hang or gum up. So, for example, if you suspend Explorer, you won't be able to open a new Explorer window for file browsing, but you may see some interactions between processes that might surprise you. Suspending one process causes other supposedly unrelated processes from continuing execution. So if that happens, just go resume the processes you suspended. That should allow what you're trying to do to proceed, and then go back and suspend the process that you suspended in the first place. The last thing that process suspend has been, for my troubleshooting, very useful for is determining what I would call second-order CPU usage. So this is a case where you've got lots of processes that are taking up CPU time on the system, and you don't really know why. So in order to kind of reduce the noise level, if you suspend a process and one or two other processes also stop consuming CPU time, you've now connected the two. One perhaps is feeding work to another. So that, for example, could help to explain why a service hosting process is consuming CPU time. If you're not sure what's happening on the system causing that service process to run, then suspend some client processes that perhaps are feeding that process work. As soon as the service hosting process stops consuming CPU time, you've now identified the process that was feeding that process work.
Well, the process display and the list of columns that you select can provide you a lot of information about a process, but sometimes you need to dig in a little bit deeper. And for that, you can look at the properties of an individual process, and you can do that in a couple different ways. The simplest way here is to double-click on the process, but you can also use the Properties toolbar menu. I'm going to look at the properties for Explorer itself by double-clicking on it and opening its Process Properties tab. The default, or Process Properties page, that is, the default tab here that it takes you to is the Image tab, which shows you some information about the process image, including the description, the company name. So we saw those in the columns that we had configured, but in case you've removed those columns, this is an easy way to get that information. The version of the image, again from the images version resource, the time that the image was created, not the time that it was installed in your machine, but the time it was created, the path to the image, the command line that was used to start the image, and the current directory. The current directory can be useful because a number of applications rely on finding their own DLLs in their current directory, and if their current directory gets changed, they might not be able to find their DLLs or might actually end up finding different DLLs than the ones that they want to use. The parent process is also shown here, and Explorer's parent actually is missing, which explains why, if we looked at the process tree, Explorer is left justified, and it doesn't show up as having a parent. That's because Explorer's parent is actually exited, and we'll talk about in the little bit later how when you log into the machine, it's not Explorer that's created as the first process that runs as you. It's actually a different process called userinit, which is responsible for setting up your network connections and running your logon script, and then it's responsible for launching Explorer. It exits after doing so, leaving Explorer as an orphan.
So should we feel bad for Explorer?
I do feel bad for Explorer.
It's a parentless process.
Yeah.
I don't like to say orphan, I like to say parentless.
Okay.
Parentless.
Parentless process. We see the user account that it's running in this case it's running as the administrator account, which is what we're logged in as, and it shows us the time that it started. Finally,
that start time, I just want to mention, Mark, is another useful tidbit. That's not available in Task Manager. Just being able to see when a process was born, when it started running, could help in a troubleshooting scenario, especially if something's stuck. You go back and look at a process that maybe started overnight, some batch job, some script. Being able to see the start time could help to diagnose or isolate when things got gummed up.
Over here, kind of in a faded effect, is the fact that this is a 64-bit process. We're running on 64-bit Windows. So we've got actually in the process tree a number of 64-bit processes and a number of 32-bit processes. Not immediately obvious just by looking at them in the process tree, but you can see that here in the process properties. By the way, you can also add that as a column if you want to easily see which processes on your system are 64-bit versus 32-bit. There are a number of buttons over here. One is the verify button. We'll come back to that later. The next is the bring to front, which is basically the same shortcut to that bring to front for a window. If that process has a window, this will bring it to the front. And then an easy way to access termination of the process. There are a number of other tabs here. The next one we'll talk about is the performance tab, which shows you various statistics related to that process's performance with regards to CPU, virtual memory usage, physical memory usage, its I/O related activity, and the number of handles it's got, not just to operating system resources, but to Windows and GDI objects, or GDI and user handles, that is. GDI are handles to bitmaps, paintbrushes, other graphical related elements. And user handles are handles to menus, to windows, and other visual window related elements. The reason why you might want to keep track of this information or look at it is that these resources are limited. So GDI and user handles, by default, you can have at most 10,000 of each on a desktop. And if you have something that's leaking one of these things, you can end up getting all sorts of strange graphical strangeness as you were using Windows. The next tab is the performance graph tab. This is kind of a process-specific version of Task Manager's system information tab, which breaks down the display into CPU usage and memory usage. We can see here that Explorer's used about 20.5 megabytes of private virtual memory and is consuming close to 0 CPU at this point in time. And you'll notice that when I move the mouse around the graph, that there's a tooltip in the upper left or upper right, depending on which side of the graph I'm on, that shows us the CPU usage at that particular point in time and also shows us the time of that corresponding to that position in the graph.
One of the details about a process that Mark showed was the command line. And I'm going to show how useful that is for identifying the role of a process now with a little demonstration. I'm going to bring up Process Explorer, and let's close the Properties dialog. I'm going to double-click on the date time in the lower right-hand corner. And notice when I do that, a process appears in the list called RunDLL, RunDLL32.exe. Well, that's one of those generic shell or host processes that may have multiple roles or purposes. Well, if I double-click on that process and go to the Image tab, you'll notice in the command line, at the end of the command line, is a reference to a CPL file. CPL files are control panel applet DLLs that are loaded inside RunDLL32. So this RunDLL32 was invoked to load or host the time-date changing applet, which we saw was brought up when I double-clicked on the date time. So it's just an example of how examining the command line adds some more detail about process state or the purpose of a process, why it was invoked, or what switches or options was passed to it.
The next tab we're going to take a look at is the Process Environment tab. So let's go back to Explorer and look at its Environment tab. This shows us the environment variables registered in this process. And the reason why it's important to show, or it's necessary to show, environment variables registered in individual processes is that despite the fact that you might go to the system applet in the control panel and configure environment variables that apply to all processes, processes can modify their own individual environment variables. And thus, there were need for an individual environment tab for each process. And this will show us what environment variables are configured for Explorer, which can affect the way that Explorer runs. If it's looking for certain directories, for instance, that are configured as configured to be defined as environment variables, this will affect its behavior. So this is useful sometimes for troubleshooting issues related to environment variables. The next tab is the Strings tab. And this Strings tab is interesting specifically for identifying malware. The Strings tab shows you the printable strings within a process, or printable characters. Not always strings that make any kind of sense, but if we scroll down, we're likely to run into a batch of printable strings eventually. There we go. A number of strings that can be URLs, they can be names of functions that this process imports, they can be paths to files and directories, or registry keys. Dave talked about packed images, and we've got an example of a packed image here. For a packed image, the strings that are in the file on disk are encrypted or compressed, and so the default view here of looking at the strings in the image typically isn't very revealing. So if you're looking at a malware process that's compressed or encrypted, it's more useful to select the memory button here. And what this will show is the printable strings that are in the loaded memory image. So in other words, after the image has unpacked itself into memory, we can look at the strings within it. And this, if we were to compare the two views here of Avant browser, its on-disk strings versus its in-memory strings, the in-memory view would have these kinds of strings, whereas the on-disk display wouldn't.
Now I noticed, Mark, if you bring that strings dialog back up, that you've got a save option.
That's
so
right.
That could be saved to disk, and then you could compare them with a differences program like WinDiff.
Or use it, load it in an editor where it might be more easy to scan through it. You can also search for individual strings. So one thing you can do is search for URLs.
That's a strange one.
That's a strange one. Let me switch to the memory view and see if we find anything more interesting. So there's one. So there's one. W3.org schema site that Avant browser is referring to. The next tab that we'll stop and discuss is the security tab. The security tab shows you a piece of redundant information, a piece of information that we saw back on the image tab, and that is the user account that this process is running in. And again, we're running as administrator, so
just one comment,
here we'll
Mark.
see administrator. Yeah.
I thought one thing that you show there that Task Manager doesn't is the security authority from which the account came. So that is the local administrator account, we know, as opposed to a domain account, because the machine name that we're using right now is mr-turion. If the process was running under a domain account, we would see the domain name / in the username. So it is possible to have local accounts and domain accounts with the same name. Task Manager would show those as having basically the same account name. Process Explorer does delineate the domain versus local account by showing the security authority.
Right. And these two sub-windows here, the first sub-window shows you the group memberships of the account at the time of the login. So we can see, for example, that the administrator account belongs to authenticated users, NTLM authentication group, this organization group, and most importantly, the group that gives it all of its power, the built-in administrator's account. Here at the bottom, we see the list of privileges that are assigned to this account at the time that the user logged on. Privileges are special security powers that give that process the ability to do things that other processes without those privileges wouldn't be able to do. For example, shut down the machine, here in the shutdown privilege, would give this process the ability to shut down the machine.
But it says it's disabled, so that means you don't have the ability to do it?
Well, part of the Windows security model is a concept of least privilege, only enabling a privilege if you actually need to use it, so that a compromise of this process wouldn't be able to exercise that privilege because it's disabled. If this process were to call the Shutdown Windows API right now, it would actually get an access denied, because the system would look to see if it has the shutdown privilege in its token, which is the data structure that we're actually peering into in this tab of Process Explorer, and would see that it's disabled. Say, you've got it, but it's disabled, so I'm not going to let you do it. So somebody that wants to shut down the machine has to enable the shutdown privilege in their token, and then they can call the Shutdown API successfully.
So just an example of that is when you go to change the system time changing privilege has to be enabled by the control panel applet, which is a DLL loaded into run-dll32.exe. And to demonstrate that, I'm going to go and double-click on the date-time applet, go to Process Explorer, find that run-dll32 process, double-click on it, and if you notice as I scroll down on the privilege list, the change system time privilege has been enabled. Whereas if I look at the parent process to run-dll32, which is explorer.exe, that same privilege is in the list, but it's in the disabled state, its default state. So run-dll32, when it started, loaded a DLL that enabled the privilege, and if you didn't have that privilege in your token, you would have gotten an error message that you don't have the privilege to change the system time.
I wanted to point out one more thing, Dave, is about this run-DLL that you looked at, is that Process Explorer, another example of a tooltip showing you convenient information about the process, is that here for run-dll32 processes, it will show you the target DLL of the run-DLL, the DLL, primary DLL that it's hosting. In this case, it's the timedate.cpl. So another way to get at it, that information, without having to open the process properties and look at the image tab and the command line.
Now, earlier, Mark, we looked at the ability in Process Explorer to run a limited process, and you said you would show us in the Security tab how the token differs between those two. So could you demonstrate that?
Yeah, let's pull that up. So what I'm going to do is do a run run as limited user, I'm going to launch Notepad. And we're going to run a regular Notepad. I could have used the Run menu in Process Explorer. So now I've got two notepads down here. And this one is the limited one, which is a child of Process Explorer. Let's take a look at its security tab and then pull up the other Notepad security tab and try to compare those side by side. And one of the obvious differences is in the privilege list. So let's take a look at that first. The limited version of Notepad only has 3 privileges, whereas the one that's running in the administrator account has a whole slew of privileges. Basically, almost all the privileges are granted to the local administrator group or account. And if we go up to the group membership list, most importantly, this has the built-in administrator's account in its group list, but it's marked as a deny group, whereas over here it's marked as the owner group. Now, what does the deny do? That is what is basically limiting the power of this process. The administrator's group can only be used against permissions to deny this process access to objects, not to ever grant it. So in other words, if there's an object that says the administrator's account is the only account that has access to this object, just because this process has administrator's group in its token, in its security context, it won't get access because the system looks at it and says, I can only use this to deny you access. So if there's another object that says administrator's account is denied access, this notepad won't have access to it either.
So for example, that notepad wouldn't be able to create a file in the Windows directory, Windows System 32.
That's right.
So again, you could use this to run Internet Explorer, Outlook, or other applications that you want to take away the admin rights to avoid the potential to compromise administrative protected data.
And that's exactly what that's for. Our next tab is the TCP/IP tab. The TCP/IP tab is useful for looking at processes' network connections. And I'm going to pull up Avant browser, which might have some network connections. Find the TCP/IP tab. And it shows that it's got a UDP endpoint open on port 1066. If we wanted to see the raw IP address, and this is useful if you see the process connected to remote sites, you could unclick the resolve addresses and then see the raw IP address. Of course, the local address is 127.0.0.1. And for TCP endpoints, it would show you the state, connected or closed, for example.
So what happens if you go to CNN.com, for example, right now?
So let's, and we can see, just as we saw in the process view, the difference highlighting shows us new endpoints show up in green, ones that have been closed show up in red, and the different states of these TCP endpoints, along with their addresses. So you can see a whole bunch of activity, taking you to places that you wouldn't expect to when you go to CNN.com.
3 other advanced process property tabs we'll take a brief look at. The .NET tab only appears on processes that are running managed executables. We're not running any instances of that, so we won't take a look at that. But that does provide access to the list of app domains inside the process, which are like virtual processes within a process. Also, easy access to the .NET performance counters. Now, processes that are a member of a job are highlighted by default in a brown color. And a job is basically a collection of processes that have some common resource quotas or limits that are specified programmatically. There isn't any built-in way in Windows to specify the attributes of a job, so this requires writing a program that creates one of these objects and then assigns processes to jobs. But it is likely that you're going to see a process as a member of a job, and one example of that is when WMI provider processes are created. So for example, Mark, if you could run your PS Info tool, and then if I switch over to Process Explorer, we should see some WMI provider processes created. In fact, there's one right there, highlighted in brown. That was created because Mark's PS Info tool is calling upon some information that is provided by WMI, Windows Management Instrumentation. Now, if I double-click on that process highlighted in brown, you'll notice that it has a tab we haven't seen before